There are a lot of things that applicators need to be aware of when they spray. They need to get the airspeed low as possible to get good coverage. They need low air volume because they don't want to be blasting too much chemical toward the crop. And in that regard, they don't want to spray over the top of the canopy. They need to be aware of the weather conditions, the wind, temperature before and during spraying. And then another key is to avoid spraying under temperature inversions. We may have still air and the spray will just hang in the air and potentially move large distances downwind. We don't want to spray when the wind is too high. 15 kilometers per hour is an upper limit for spraying. And then we certainly don't want to spray if the air is very dry, which is a high delta T condition because of evaporation. We're just going to lose all the spray. Don't spray when the wind is toward a sensitive area. So if there's a crop downwind that could be affected, or people, houses, watercourses and other neighbours around where we're spraying. Drift reduction technologies in vineyards can be products, equipment and chemical formulation that we can avoid small droplets, the very small droplets that will drift. We might have specialised sprayers, tunnel sprayers, recycle sprayers, modifications to sprayers like shields and shrouds to physically prevent spray drift. Spray components such as the nozzles, the spraying system that we're using, and then the chemistry is just as important as those physical things. We need good adjuvants, we need good chemistries. Finally, if we do have some spray drift leaving the area, then we need a good barrier around the property to catch the drift. Hedges, netting, things like this can help us to catch and prevent spray drift leaving the property boundary. GWRDC has invested in a large research program over 5 years at the University of Queensland in Gatton, and we're looking at many different drift reduction technologies, nozzles, adjuvants, and various other ways of improving through the equipment and the chemistry what we're doing on the crop. All of the data from this project will be provided to regulators such as APVMA so that they can see how much chemical lands in the canopy, how much is mid-row and how much is lost to drift downwind for each drift reduction technology or DRT. When we understand how much drift we have or we can reduce by using the DRT, then we can make a better decision on our spraying. Ultimately, we're trying to drive innovation and DRTs within the wine industry, which will give us a reduction of mandatory no-spray buffer zones. We're doing a lot of the initial screening work in a wind tunnel, so we're able to take hundreds of different nozzles and tank mixes, screen those in a wind tunnel, measure the droplet size, measure the spray drift, before we then go to the field with the best of the best. So we then take the full applications, new spraying systems and chemistries to the field studies for the final part of the testing each year.
Well, the main part is a large electric fan, and the air is actually a laminar flow, so it goes through a series of screens, so it's not turbulent, so it's a nice laminar flow. The air then passes over the nozzle that we're looking at. Plumbed into that nozzle will have a particular tank mix, and the measuring instrument is actually a diffraction laser. It gives us a droplet spectrum, so it shows us what's called the volume median diameter, or the VMD. So half your spray mixture consists of droplets which are larger than that value, and half your tank is with droplets that are less than that value. The other thing that it shows us is the percentage of driftable fines. Fines are your droplets that are less than 100 microns, and they're the ones that do the damage. They're the ones that drift in the wind and do the damage. So farmers need to know what percentage of fines they have when they're using a particular nozzle with a particular tank mix at a certain pressure.
The National Working Party on Pesticide Application in Australia, which consists of a wide range of stakeholders including GWRDC, is going to use the results of this project in combination with other research for a wide variety of crops. The data will be provided to regulators, APVMA and others. And at present, the current regulations, including recommendations on chemical labels, don't reference DRTs. The main reason for that is they don't have the data to support DRTs, so we're going to provide regulators the information that they need to recognise the importance of DRTs. It's equally important for the wine industry to seriously look at the DRTs available to improve deposition and reduce drift for their own purposes.